Well, welcome to 8-2, day 2. We're going to start to solve some trig equations that are a little bit more complicated. Okay, we're gonna do 4 in this lesson. As always, when we're doing kind of repetitive skills and looking at multiple examples that are the same, if you get the hang of it, well, then pause, keep going. You know, if you've got the notes outlined, just you have the problems that we're going to do, try them yourself and use the video as an answer key. But we always want to be building towards doing these problems on your own. Okay, the sooner we can get there, the better. Okay, so at any point in time that you feel confident, just go off on your own and then use this video as an answer key. 2 sine of x equals 1. Okay, this whole time we're going to be working in radians. Okay, we're going to be working in radians. We talked in the first day of 8-2 that the coefficient in front of x changes the period length of the graph. Okay, how quickly it repeats. Here it's 1. So the period, and this is always something, even though we're not doing any graphing, I do want to be aware of the period of this particular sine graph. It's 2 pi. The big thing that means is I know it's going to have 2 solutions, and that's it. Okay, if the period has been changed, I can have more, and I have to be very aware of what the new period is to get those other solutions. First step here is to divide by 2 to get it in the form of something that I can use an inverse. Okay, now I should always be checking for answers that are, well, let's call it unit circle friendly. Okay, that they represent key points that are on the unit circle. This one does. Okay, this one does. There's 2 points on the unit circle. In radians we're talking here. Pi over 6, that has a sine value of 1/2. And 5 pi over 6. And again, I know I'm done at that point because I've been paying attention to the period of the graph. It hasn't been changed. And there's 2 solutions, and I know I've got both. Okay? If I wanted to generate other solutions, I could think about coterminals, and with either one of those, I could add or subtract 2 pi. That's going to take me out of the interval that I'm solving for, and I don't need to do that. The instructions on all these problems are going to be to give all the solutions from 0 to 2 pi. Okay, nothing more, nothing less. I've got both at this point. Now this example basically looks exactly the same, except notice in here 2x. Let's think about those graphing basics that we talked about. The period of a sine graph is 2 pi unless it's been adjusted. Here it has. That period is going to be 2 pi over 2, which equals pi. It's been shortened from 2 pi down to pi. Okay, just a really super basic sketch. This is not necessarily going to be accurate at all. The original sine curve would look something like that. This graph has been stretched out with its amplitude, but its period has also been adjusted, so this graph is going to look something like that. Okay? Now, I have to be aware of the solutions here. This is going to have more than 2, because if I were to just solve it using the inverse, okay, and I'm going to go ahead and do that right now. Okay, I divide by 2 just like I did the other one. I get sine of 2x equals 1/2. Okay, this would be the point where I should take the inverse sine, because that's the next step in order of operations. That undoes the sine, and I get 2x equals pi over 6. And 2x equals 5 pi over 6. Multiplying both of those by, dividing by 2, pardon me, I get pi over 12. And x equals 5 pi over 12. And if we weren't paying attention to this adjusted period of the graph, we would think incorrectly that we're done and we've got all the solutions from 0 to 2 pi? We don't. Okay, we don't. We have solved this for both solutions that are from 0 to pi, which is now one period of the graph. Okay, now it's not horrible to get the others. If we take the new period of pi, to either one of these solutions we can add or subtract pi, and we'll get the others. Okay? So let's get some other solutions here. I've got pi over 12. If I were to add 12 pi over 12, okay, that's pi. It's just got a common denominator. I would get 13 pi over 2. That's a solution I want. It's less than 2 pi. I've got 5 pi over 12 plus 12 pi over 12. 17 pi over 12. That's less than 2 pi. Okay, I'll take that one. If I were to do it again, I would see the next solutions take me outside of 2 pi. Okay? But adding or subtracting 2, or in this case pi, will give me all the other solutions that I need. Now, again, before we even get started, let's pay attention, seeing right here, we have been messing with the period of the graph. It's been adjusted. Okay, this is a huge and super important equation that we have to really know. 2 pi over b is the period. Okay, I have 2 pi over a half. That's really what's going on with x over 2. That's a half. This period of the graph is now 4 pi. Okay? 4 pi. It's been lengthened instead of shortened. Now, keeping that in mind, it's always important to know that that's an extremely important number. It impacts how we solve and get all of our answers. Divide by 2. That cancels. I get sine of x over 2 equals negative 1/2. We're still dealing with key points on the unit circle. There's 2 places on the unit circle that have a sine value of negative 1/2. One of them is 7 pi over 6. The other is 11 pi over 6. Okay, now to get the actual solutions, I would multiply both of these by 2. Seven pi over 6 times 2 is 14 pi over 6, which is 7 pi over 3. There's a solution. 11 pi over 6 times 2 is 22 pi over 6, which would be 11 pi over 3. Now remember, the instructions from the very beginning were to solve this for x from 0 to 2 pi. Okay, now we've been saying the whole time, and the big point I've been emphasizing is that number, that adjusted period, which again comes from this, the fact that x has been divided by 2, it has an impact on how many solutions that we have. And we saw in the first and in the second example, it led to 2 additional solutions. Look at this one. 11 pi over 3. If I use the common denominator of 3, 2 pi is 6 pi over 3. 11 pi over 3 is bigger. Okay? I don't want that solution. This is the only one. 7 pi over 3. So in example 2, we saw when the period is shortened, it led to more solutions. Here, when it's lengthened out, it leads to fewer. We only have 1 instead of 2. Okay, one more example. Before I even do any solving, I want to pay attention to the period. That's 2 pi over b. Very important to recognize from this example that b is 3. There's the period. Okay? That is going to affect how many solutions I have. When I just solve and then use the inverse to get 2 of them, there's going to be others. I'm not expecting to just have the 2 that I typically get. Let's divide by 5. We get cosine of 3x equals negative 0.4. This would be the point where I do the inverse. Negative 0.4 does not look like a key point from the unit circle. So I go to my calculator, I do the inverse, and that rounds to 1.98 radians. Now here we have to remember our rules. Okay? Remember, if we're taking an angle and looking at its cosine value, in 8.1 we saw the rule is if we want to generate the other angle that has that cosine value, we do 360 minus that angle. So I need to do 2 pi minus 1.98, and I get 4.30. Now I continue on here, divide by 3. One of my solutions will be 1.98 divided by 3. That is 0.66 radians. This will give me my second solution, which would be 4.3 divided by 3, 1.43. Okay, now because we're having to go to the calculator here, we're dealing with decimal approximations. And we're solving this from 0 to 2 pi. So let's think about 2 pi as a decimal approximation. It's about 6.28. Now these two solutions are definitely between 0 and 6.28, so I want them. But how do I get the others? Okay, there are going to be other solutions. How do I get them? Okay, this goes back to this 2 pi over b. If I take either one of my solutions, like 0.66, and I add or subtract, and I can use a decimal approximation here. If I add or subtract 2 pi over 3, that will give me the other solutions. Likewise, if I take the other solution I got, a 1.43 radians, and I add or subtract 2 pi over 3, that will lead to other solutions. I want all of them that are between 0 and 6.28 radians. Okay? I'll leave you here. See if you can find the others by adding or subtracting 2 pi over 3, and I will give you the hint. There are 4 more solutions. Okay, we have found 2. There should be 6 total. Okay, find 4 more. Next time we see each other in class, let's talk about it and see if you can come up with the other 4.